Alright, boys and girls, here we go. Let's work on some piecewise functions today. But before we get to piecewise functions, what I would like you to do is I would like you to just quickly review questions 1 through 4, just finding f of 2, g of negative 2, where you substitute back into the original function. Just click the video or pause and give those a try for about 30 seconds. So f of 2 is equal to a negative 3 times 2 plus 2, because all we have to do is substitute 2 in for x. It's going to give us negative 6 plus 2. F of 2 is equal to a negative 4. G of negative 2, that's going to give us a negative 2 squared minus a negative 2 cubed. Negative 2 squared is 4. Minus negative 2 cubed is a negative 8. That's going to give us 12. F of negative 5. So that's going to give us negative 3 times a negative 5 plus 2. That'll give us 17. And finally, G of 0 is going to give us 0 squared minus 0 cubed, which is 0. So that's just a little quick review, because what you are going to start doing is working with piecewise functions. Now, piecewise functions can have multiple steps, 2, 3, 4 steps involved. So what becomes very important is the domain of each part. So as you can see, for number 5 and 6, this f of x has 2 parts. The function is 5x minus 1, but that's only when x is less than a negative 2. When x is greater than or equal to a negative 2, the function is x minus 9. So, to find f of negative 5, before you even start substituting negative 5, you got to figure out which one you want to substitute it in for. Is negative 5 less than negative 2? Yes, it is. So this is the function that you want to substitute it in. So we have 5 times a negative 5 minus 1, which is going to give us a negative 26. Okay, but for number 6, we want f of 5. Is 5 less than negative 2? No, it isn't. So you have to go to the next one. Is 5 greater than or equal to negative 2? Yes, it is. So we're going to substitute this one into the bottom equation. And you get negative 4. That's piecewise functions. They are still functions, but they have multiple pieces to it, and they're separated by a domain. So you get to pause the video and try h of x. I want you to find h of 0, and I want you to find h of 10. Go for it. And h of 0 is less than 6, so you have 1/2 times 0 minus 10, so you get a negative 10. And then for h of 10, 10 is greater than 6, so you have a negative 10 minus 1, which is a negative 11. And that's evaluating piecewise functions. What becomes even more fun is graphing them. Graphing them is a little tricky, but if you understand how to graph lines in y equals mx plus b form, these are really not that bad once you practice it a few times. So I'm going to give you a few, shall I say, tips for pre-game work that'll help you with these and help you be more accurate. So it's a little bit more work than is required, but you'll have better results when you're done. So the first thing is you got to figure out where you're going to start each piece. And to do that, all you do is you take your domain and substitute it into the equation. So x is a negative 3. So you substitute it in here and you get negative 3 plus 6, which is a positive 3. And that goes into your y coordinate. That's your starting point. Okay? Now, what else can we say about the starting point? Well, just like in chapter 1, less than or equal to. Less than or equal to is going to have a solid dot at that point. Less than means it's going to go to the left. And the last thing I tell people to write is list the slope as well. The slope of this is 1. And once you list that information, before you start graphing it, go list your other information. So again, you're going to take your domain where x is -3, and you substitute that into this x. So then you have -2/3 times a -3 minus 3, which is going to end up giving you 2 minus 3, which is a -1. Okay? And then you list the type of dot. X is greater than, so it's going to be an open circle going to the right, and our slope is a -2/3. So let's go graph. Go back to the first one. The reason why you substitute this in to here is so you can get your starting point, which we found is -3, 3, and it is a solid dot. Now this is the part where you need to be careful. You're very trained with slope of 1 to just go up 1 and right 1 because it's a positive slope. But remember, you could also go down 1 and left 1, because down was negative, left is negative, double negatives turn into positives. So you look at this and you go back to this where I said x is less than, less is left. You actually start at your -3, 3, but you're going to graph to the left. Now I know what you're thinking, why am I going down if it's a positive slope? But it is a positive slope because you're going down and left, which is a double negative. Once you are done graphing a line, I highly recommend that you see if that line is going in the right direction when you read left to right like you're supposed to with graphs. Is this going up as you read left to right? Yes, it is. So it does have a +1 slope. So now we're going to go to our second piece. We have -3, -1 with an open circle. And then you are going to go to the right, but we need our slope of -2/3. So your standard is down 2 over 3. Are you going in the right direction already? Yes, you are. So then all you have to do is graph this and then stop and use a little bit of common sense. This one has a positive slope, so it's going up. This one has a negative slope, so it's going down. And if we read this, this graph should go up then down. And does it go up then down? Yes, it does. So that's just looking when you're done. That has absolutely nothing to do with your final answer. This right here is your final answer. And yes, it is still a function because look, if you try to draw a vertical line, you hit a graph, but then you hit an open circle, which means it just represents a placeholder. It's not part of the actual graph, so it does pass the vertical line test. That's why piecewise functions are in fact functions. So if you found that a little tricky, I recommend that you rewind and you watch it again, and then come give number 10 a try on your own. Go ahead and pause. Come back when you're ready. So we're going to go back. This is when x is greater than 2. You got to be careful. Kind of tricked you a little bit on this one. So you've got a 2. So you substitute your 2 into here. And we have 2 comma -2. That's your start. Our slope is a -1. We have an open circle going to the right. Now that doesn't usually happen. When you list these, they usually go left to right. But we want to make sure that you're paying attention at all times. The second one, you take your 2, substitute it into here. So 2 minus 4 is a -2. And we have a slope of a +1. This is going to be a solid dot to the right. I'm sorry, to the left. Look at me, force of habit. So then we're going to go back. We're going to take our 2, -2, and we are going to put an open circle to start. This has a slope of -1, down 1 over 1, and we are in fact going to the right, so we're going to just go to the right. Now the green one is a solid dot on the same coordinate. Now it's okay to color that in. It's okay to color in an open circle once you have another piece involved. And then we have a slope of a +1. Remember, +1 is up 1 over 1, but we can't go this way Because this graph is going to the left. X is less than. So we're going left. So that means if we follow the pattern to keep this aligned, we should be going this way. And then we go erase our green dot over here because we want it to pass the vertical line test when we're done. Alright, so that one's a little tricky. You had to see if you were paying attention. Always make sure you pay attention to your domain over here. When you're done, remember these are functions. They will pass the vertical line test. So if you are watching carefully, if you would have gone the purple way that I just did on accident, when you did this, would it pass the vertical line test with the blue line? No, it wouldn't. And these are piecewise functions, not piecewise non-functions. So that would just be a little common sense trick to say, hey, am I right or wrong? And if you're not passing the vertical line test, chances are you're wrong. Last example is called a little step function. So remember, when you have y equals 1, that's a horizontal line. Y equals -10, that's a horizontal line. Whenever you have a bunch of numbers, these are all horizontal lines. You don't need a slope. You don't need a slope at all. So what you need to do, though, is you just need to graph them from here to here. So this is y equals 1 when x is -4 to -3. So you're just going to have a solid dot on a -4 and an open dot on -3. And you just do that. It's a little step. Then we work our way up to level 2. We have a solid dot on -3 and an open dot on -2 because this goes from -3 to -2 at level 2 only. Then we're going to jump up to level 3, but only from -2 to -1. So we jump up to level 3 from -2 to -1, and we're done. And finally you finish at level 4 from -1 to 0. And you are finished with a step function. Okay? So that concludes our first day of piecewise function notes. We are going to have another day of it following. They will get a little bit more complicated with possibly 3, maybe even 4 pieces. But you guys can handle it as long as you remember to always get some starting points and give yourself a little bit of work. I understand it's more work than what you think might be required, but your results will be better when you're done. So that's it. This is Longo, and I'm out of here. Have a great day.